Hey guys, it's the middle of office hours right now. Enough people have come that I felt like I should post everything we talked about. And the first question people asked about a lot was number 9 and 1.3. And so I didn't want to do exactly that problem for everybody. So here is a similar problem, and I'm going to walk through it. So first, I'm going to take that hideous rational function and I'm going to write the general form of its complete partial fraction decomposition. So first I'm going to factor the denominator. And now the degree of the numerator is 2 greater than the degree of the denominator, so I'll start out with, or 1 greater than the degree of the denominator, so I'll have ax plus b plus some number c over the 2x minus 3 plus some number d over the x minus 4. We're going to work with the ax plus b first by doing polynomial long division, because who doesn't love a good polynomial long division? So here's our rational function, so I'll go ahead and set up my long division. And now the first question I need to ask is, what do I multiply 2x squared by so that I can cancel out that 10x cubed? So 5x, so I'll multiply 2x squared minus 11x plus 12 through by 5, and then I'll subtract. My first term will cancel, and I'll bring down the 42 when I'm done. And now I'll take the 2x squared and multiply it by 3 to be able to cancel out the 6x squared. Multiply the 3 through by everything. I'll subtract, and I'll get x plus 6, which will be my remainder. And what that means is that this hideous rational function that I started with can be written in this form, but I can replace a and b by 5 and 3. Okay. So what's next is to find c and d, which is going to be equal to x plus 6 over that hot mess. So we'll work out that next. So x plus 6 over my polynomial is equal to c over 2x minus 3 plus d over x minus 4. I'll multiply both sides by 2x squared minus 11x plus 12, but factored out. On the left-hand side, that whole thing will cancel with the denominator. But on the right-hand side, only one of the terms will cancel in each pair. So I'll have x plus 6 is equal to c times x minus 4 plus d times 2x minus 3. I'll start by letting x equal 4. And then the c term will be multiplied by 0. And I'll get 10 equals 5d, so 2 equals d. Next, I will let x equal 3 halves. And when I do that, the d term will be 0. So 15 over 2 equals c times negative 5 over 2, so c is negative 3. And what that means is that this whole rational function can be written as x plus b plus c, but we found c and d, so we're good. So now when we integrate this rational function, that's the same as integrating this decomposed form. The 5x plus 3 is easy peasy lemon squeezy. And then so are the other two. Just remember the u substitution for that 3 over 2x minus 3, which will mean you're multiplying by 1/2. Okay? All right.